Hello, my name is Matthew Eckelberg, and this is my video voiceover for assignment 2.3, Dimensional Design. The purpose of this assignment is to explain and illustrate dimensional modeling techniques, describe major components of the dimensional modeling process, identify the role of each component in the dimensional modeling process, explain how it all relates to the chosen company. If you remember from last week, my chosen company is Tencent Holdings, the Chinese company falling in at number 74 on Forbes Global 2000 list. They are an investment holdings company conducting those services. Quick overview on what I am going to cover today. I'm going to explain my plan to install the 4-step dimensional design process for Tencent Holdings, my plan on handling basic fact tables, some insight on OLAP cubes, a dimensional design diagram that I created, EDM schemas, and then, of course, a summary. The 4-step dimensional design process. This image kind of lays it out for you, but we're going to go over these one at a time. So first up is select the business process. There must be a clear-cut goal for what we want out of this BI project/solution. So my plan for completing step 1 would be to conduct an initial meeting or a discovery meeting, whatever you want to call it, to identify just that. What is the goal of this? What is the end game? And as far as who's sitting in on that meeting are primary stakeholders, management, champions from across various departments, and the IT department. And we will hash those things out and come out with an answer for step 1. Step 2, to clear the grain. This should also really be covered in that meeting as well, because it will come kind of natural. What do we want out of this? What is the goal? And what is the level of granularity that we need from this BI solution? After we have those two answers, step 3 should come fairly natural as far as identifying the dimensions. So if my goal is I want to find out how well this particular game sold in this region, the southeast region of the U.S. Well, that's more or less one of my dimensions right there, is a southeastern region. So things of that nature. And then step 4, of course, identifying the fact. So find the fact that will correlate to that dimension. So if Bob, the manager, is asking a specific question and knows the dimensions that he wants to apply, what fact is going to give him that answer? And then from there, you build the schema. This will benefit things such as games, features, marketing tactics, etc. I talked a little bit about this in my last week's presentation. And then, of course, ultimately, the whole goal is, as all things that we read about in EDM, is to enable a company to make more data-driven decisions. My plan for handling basic fact tables is rather simple. Step 1 consists of just communication with the DBA, database administrator, whether it's our own DBAs, but as well as external companies' DBAs. Because as I will get into later, the way Tencent Holdings should, at least in my opinion, implement this dimensional design is with a star schema, where Tencent Holdings creates the dimensional tables, but requests or retrieves the fact tables from the external companies. So that'll make more sense in a few slides, but just communication with external and internal DBAs is crucial. Secondly, using OLAP would be very useful here. OLAP allows you to view multiple data sources or databases at once, so that will be very, very crucial in this case. And then, of course, just creation of those ER diagrams and giving extra care to those foreign keys. By having solid ER diagrams, it's just going to make the whole process that much easier. Moving on to OLAP cubes. OLAP stands for Online Analytical Processing. OLAP is a software that enables the user to view data from multiple databases at a time. Often, and well, most often, OLAP will be referred to as a cube, as you can see in this picture. It is very helpful when you are accessing more than two-dimensional data. Two-dimensional data is data values are arranged in a row and column format, whereas OLAP contains multi-dimensional data, as you can see in that image. It's much quicker because it can reference multiple dimensions of data at once, and this data is also pre-calculated because before the data is loaded into the OLAP cube, it is cleaned and transformed, making OLAP very fast and efficient. Tencent, as I mentioned, does a lot of business with a lot of different companies, so I believe that they would benefit greatly from the use of OLAP cubes. So, dimensional design diagram. So this is the diagram that I actually created. As you can see, it is a star schema with the one fact table in the center and the dimension tables all deriving off of it, providing context to those facts. This is a very simple example. It is not completely filled out. It does have some small, examples of what could be as far as pertaining to Tencent, with the gross return, net return, customer age groups, units sold worldwide, region-based. These are dimensions that Tencent could potentially be, or would potentially be interested in. And then those facts would come from the companies themselves. So there's a solid set of dimensions and measures. So this is the reason I'll get more into the star diagram the next slide on why I chose it. But I see this being more efficient in Tencent's case because the dimensions really shouldn't change. What they're trying to measure as far as what is a successful investment and what is some business that I want to continue doing, that picture shouldn't change. The only thing that's going to change is the facts, and the fact table can be derived or retrieved rather from the companies that they're investing in themselves. Again, because they're going to want to look at things such as performance metrics, sales, etc. Fact tables from the companies, dimension tables from Tencent. So getting more into the EDM schemas, as I mentioned we would, what we have here is the star schema and snowflake schema. More or less, they're very similar. They both have facts and measures in the center, but where star schema goes to a single dimension, snowflake schemas almost have dimensions that are multi-layered, if that makes sense. So we'll look at the pros and the cons. The star schema, it's faster, less complex, as you can see, and higher redundancy, which isn't necessarily a great thing. We have some duplicates there in the data, but it's faster, and with high redundancy does come more disk space. Snowflake schema, obviously, it's going to be slower, more complex, but it's a normalized data structure. Lower data redundancy and takes up less disk space with that. So, a quick summary. We went over the 4-step dimensional design process, went over the plan for handling basic fact tables. We talked about the OLAP cube, dimensional design diagram, and compared star schema versus snowflake schema. And of course, the summary. And that's it. Thank you very much for taking the time to listen to my presentation. My name is Matthew Eckelberg, and I hope you have a great day.